you've got to just mix it up. So it's maybe the wind, hurricane came through and mix it up. And then it's a nice food coloring. Oh, good on you, Susie. It's still got that tape stuck to it. So I'll get a load myself. I'll just state it up with a bit of nice special 3.2 milliliters of food coloring. And then camera's ready to roll. And we'll just see what happens. See if you can guess what's going to happen. Go. So I guess you can see what's happening here is the intermediate density, because I mixed it right with some blue dye. When I pulled out the divider, what did it do? It slotted its way in between the fresh water on top and the salty water underneath. And it's a propagating wave, and so it hits the other end, bounces, and then comes back, and it'll oscillate back and forth. It's almost frictionless. So there it is. You've just got intermediate layer. And so in the world of using our terms from the previous lecture, this is the thermocline because it's slightly warmer. This is a pycnocline because it's change in density. That's pycnocline means sudden change in gradient. It's also halocline because I've gone from slightly fresh, actually very fresh to be honest, to salty. And it's a nutricline if this is the open ocean because there's less nutrients here and lots of nutrients down there. So now you've got this very stable system, and it would stay like that for weeks. In fact, we'll leave it there till next Friday if you wish. It'll still be there. A bit of diffusion's going on. It'll start to thicken up, but it'll stay like that. It's remarkably stable. So when these situations occur in the open ocean, and you've got this, and it's even far more subtle variations in just a tenth of a degree of temperature or a tenth of a part per thousand of salinity is enough to make this like oil and vinegar. And it takes tremendous energy from a hurricane to punch down that layering to stir it up. And why that's important is to get mixing and to get nutrients and allow sunlight to penetrate. So that's the first thing. Second thing is to remember that the ocean is not just one big uniform bathtub of water. It ain't. It's complicated by different layers. So if you're a marine park specialist and you're trying to understand connectivity to where the larval fish or larval lobster go to justify having marine parks to improve fisheries, which is a huge issue, but they have, by the way, we'll do this in the last few lectures, they have proven this with genetic techniques. But the water flow, if your larvae in this layer, they'll go in a different direction to the larvae in the bottom layer because of these different layers, different densities, different currents and directions. So you really need to understand the layering of the ocean to understand the movements. And thirdly, I trust that you all had a shower this morning and flushed the toilet, and that water all goes down to the sewer system out through 3 major discharge points off the coast of Sydney. One's off North Head, one's off Bondi Beach, and one's off Malabar. These were designed back when I first got back from Canada in the 90s, early 90s. They opened up these big long tunnels that cost many hundreds of millions of dollars, and they go out to 60 meters deep. And that was considered by the oceanographers to enable that this stratification should be there so that when the sewage comes out, which is brackish water of poo and soap and so on, that it would come out and then they look like gas burners. That diffuses it and it floats up and gets mixed in and it gets trapped beneath the thermocline. Because prior to that, during the late 80s, it was shocking when turds would wash up on Australia's famous beaches. And tourists would it was just such a nightmarish health hazard. And the state government had to keep tourism going, was to put in these tunnels. And the oceanographers were right. They said that with this system, that 95% of the time, this will allow the stuff to be trapped beneath there and will disperse up and down and be taken up back into the ecosystem. The 5% that it doesn't is in midwinter, when the storms are so big, it's so cool up here that there's mixing from top to bottom, and then the sewage could potentially go to the surface, and if there's an onshore wind event, then we could get sewage washing up onto the beach, but that's in the middle of winter, and who's there? Only Canadians and Englishmen. So that was their solution to it. So, and it does work, it's true. 60 meters offshore. So there you go. I'm cutting into valuable Josh and Sam time. They're paid by the